He's released 2 new papers about 3i Atlas, and he's joining us now to talk more about what he found, what's new. Thanks for your time once again.
It's a great pleasure to join you.
All right, what's in the new papers?
Yeah, so the most exciting development is that in about a week, on January 22nd, the Earth will be between 3i Atlas and the Sun. And that is to a precision of 0.69 degrees. A very precise alignment that we are very fortunate to have. It's sort of like having a guest and then realizing how fortunate you are in terms of the circumstances. Now, what would that allow us? Because we would be just between the sun and this object, we will see the reflection of sunlight from the object and from any dust or gas around it from the direction of the sun. And that means that we should expect a brightening of the object on the 22nd of January, because usually when you look at dust from the direction of the sun, you can get an enhancement in the reflected light. Because first of all, if you imagine a particle being illuminated by light, when you look at it from the direction of the sun, you're seeing it in full. You're seeing the full face of it, just like when we see a full moon. But in addition to that, there is a quantum mechanical effect that enhances backscattered light. In other words, the light that is impinging on any particle is reflected with constructive interference. So you end up getting a larger signal, larger brightness, because you're looking at it exactly from the direction of the sun. And by the way, there was an interesting reply from the CIA, the Central Intelligence Agency, to a FOIA request for any records related to 3i Atlas. And the reply was not, we don't have any such records. It was, we cannot confirm nor deny the existence of such records. And that is interesting, because there must have been some discussions there. And the question is why? And I suspect it's because they wanted to be sure that it's not a black swan event. Now the intelligence agencies are quite alert to low probability events that have large impact on societies.
A rare celestial event is about to unfold on January 22, 2026, as Earth will align precisely between 3i Atlas and the Sun. With an astonishing 0.69 degree angle between Earth, the Sun, and 3i Atlas, this alignment offers an opportunity unlike any other to peer into the unknown. For astronomers, this is more than just a moment of cosmic precision. It's a chance to witness a dramatic opposition surge. When 3i Atlas aligns in this way, the light reflecting off the object and its surrounding dust will be amplified, providing a brightening effect that reveals details never before seen. This surge isn't just a visual phenomenon, it offers a unique glimpse into the object's composition and structure. As the Earth lines up with this interstellar traveler, could we be standing on the edge of something far bigger than we realize? In another intriguing development, the CIA has refused to confirm or deny any records related to 3i Atlas, despite the growing public interest and the object's highly unusual journey through our solar system. This response came after a FOIA request submitted by John Greenwald Jr., which sought transparency on the matter. The CIA's refusal to disclose any information, stating they could neither confirm nor deny, has sparked an unsettling wave of speculation. Why would the CIA remain silent about an object that is already widely known and studied by astronomers? With such secrecy surrounding 3i Atlas, the January 22 alignment takes on even greater significance. As Earth positions itself perfectly to observe this interstellar object, we may uncover truths that have long been concealed. When 3i Atlas will align with Earth and the Sun, the amount of light that will reach us is not just amplified, it's transformed. In simple terms, this event will cause the object to appear brighter than ever before, allowing scientists to study its surface and composition with a level of detail previously unattainable. The phenomenon, caused by light scattering and polarization, will give astronomers unprecedented insight into the dust that surrounds 3I Atlas. The composition of this dust could reveal important clues about the nature of the object itself. Is it made up of tiny particles we typically see in comets, or are the particles much larger, perhaps far more significant in their size and composition? These are not idle questions. The dust surrounding 3I Atlas may hold the key to understanding its origins and whether it's truly a natural object or something else entirely. As the light reflects from the dust in the alignment, scientists will be able to determine whether these particles are small, like those typically seen around comets, or whether they are larger, at least 100 times the size of typical cosmic dust particles. This is crucial because large particles behave differently in space. They are much less likely to be pushed around by solar radiation, making it possible that they could remain intact over vast interstellar distances. If the dust around 3I Atlas is indeed larger than what we normally encounter, it could mean that the object itself is more than just an ordinary comet, perhaps even something artificial in origin. The opposition surge offers more than just a chance to measure the object's physical properties. It provides a rare window into the broader question of how such objects behave in our solar system. 3I Atlas, traveling from outside our solar system, behaves unlike anything we've observed before. It doesn't exhibit the traditional cometary tail most objects from our solar system have when they approach the sun. Instead, it releases dust and gas, but in a very unique manner. Instead of a simple tail extending away from the sun, 3I Atlas seems to eject particles in a way that points directly toward the sun, an effect that's not just intriguing, it's perplexing. Why would an interstellar object behave this way? Could there be an underlying mechanism we don't yet understand? Or is there a far greater story unfolding, one that stretches the very limits of our understanding of cosmic phenomena? As the scientific community eagerly prepares for the January 22 alignment, the CIA's refusal to disclose information about 3I Atlas has sparked growing speculation. This unusual response hints at the possibility that 3I Atlas may be far more significant than a typical interstellar object. However, another interpretation of the CIA's response is that some government officials may have viewed 3I Atlas as a black swan event, a highly unlikely yet potentially catastrophic event that must be taken seriously. While experts in the field of comets and astronomy regard the possibility of such a threat as low, the potential impact of an unknown object entering our solar system demands careful consideration. By acknowledging such a possibility and keeping it hidden, the CIA may have been protecting the public from unnecessary panic. If this interpretation is correct, 3I Atlas may be the first astronomical object for which this unique approach to communication was used, allowing agencies to assess the situation while maintaining calm in the face of uncertainty. As 3I Atlas reaches its closest alignment with Earth, astronomers will have the rare chance to measure its polarization. Polarization, a change in the way light waves oscillate, can tell us a lot about the materials that reflect that light. When scientists observe how light from 3I Atlas behaves as it reflects off its surface and dust, they can gather clues about the size and composition of the particles, as well as their behavior in space. This will be a vital opportunity to learn whether the object is just another comet or whether its strange trajectory and behavior hint at something more mysterious. Over the past few months, astronomers have been able to observe increasingly detailed phenomena surrounding 3I Atlas, and some of these discoveries have left experts scratching their heads. One of the most striking findings came from the Hubble Space Telescope, which captured high-resolution images revealing a jet-like structure shooting out from the object. At first glance, this might seem typical for a comet, as many comets are known to eject material as they heat up near the sun. However, what sets 3I Atlas apart is the behavior of this jet. Unlike the usual straight jets that we observe in other comets, 3I Atlas exhibits a wobbling motion, as if the jet is rotating or shifting over time. This is not just an odd detail, it's a pattern that has never been observed in any other comet or interstellar object before. This wobbling motion has significant implications for understanding the dynamics of 3I Atlas. By studying the way the jet moves, astronomers have been able to calculate the rotation period of the object, which has been estimated at around 7.2 hours. This finding is crucial because it indicates that the behavior of the jets is not a random or passive reaction to solar radiation. Instead, the wobble seems to be directly tied to the object's rotation, with the jets shifting in sync with changes in the object's brightness. This correlation suggests that the jets are not just a side effect of the object's proximity to the sun, but rather a fundamental aspect of its behavior, controlled by its rotational mechanics. The way the jets wobble and the brightness fluctuations match so closely could reveal key insights into how the object is structured and how it interacts with the forces acting on it, possibly indicating that 3I Atlas is much more complex and much more intriguing than a typical interstellar visitor. These observations align perfectly with data collected from ground-based telescopes, which also showed variations in brightness over a period of about 7.2 hours. The agreement between the Hubble data and Earth-based data is remarkable, as it confirms that the rotation period and the activity observed in 3I Atlas are not random, but a consistent feature of the object. This opens up the possibility that the object's behavior is governed by more predictable factors than previously thought, which is critical for understanding the nature of its movement and its future trajectory. As the 3I Atlas nears its closest point to Earth, scientists are eager to gather as much data as possible to piece together the full puzzle of its origin and composition. Yet, there are still lingering questions surrounding 3I Atlas that defy conventional explanations. One of the most puzzling features is its unusual polarization. Polarization is a well-known phenomenon observed in comets, where sunlight scatters off the object's surface and creates a predictable pattern of light. However, the degree of polarization detected in 3I Atlas is unlike anything astronomers have ever seen before. Typically, comets display a certain level of polarization due to the dust and gas surrounding them, but the negative polarization observed in 3I Atlas is far more extreme. This characteristic, which has never been documented in such an object, sets 3I Atlas apart from any other comet or asteroid previously studied. This extreme polarization raises the possibility that 3I Atlas might not be a natural object at all. The way the light scatters around the object suggests a much more complex structure than what we usually observe in interstellar visitors. Such strange behavior in light scattering could point to a technological origin, prompting scientists to consider a provocative theory. What if 3I Atlas is not simply a cosmic visitor, but rather a technological artifact, perhaps something left behind by an advanced civilization? This possibility, though speculative, cannot be dismissed given the object's unusual characteristics. The more astronomers examine the light and the behavior of the object, the more it seems that 3I Atlas might represent a profound discovery that challenges our understanding of what interstellar objects can be. Avi Loeb, one of the foremost experts on interstellar objects, has long suggested that 3I Atlas may not be a natural object at all. While this idea has garnered some attention and skepticism, the data that will be collected during the January 22, 2026 alignment could provide some of the most critical evidence to date. Could this object, with its perfect trajectory, its strange behavior, and its anomalous polarization, be a messenger from another civilization? Or is it simply an incredibly rare cosmic anomaly? These questions, though speculative, cannot be dismissed lightly. The sheer rarity of such an alignment, coupled with the object's oddities, makes it an ideal moment to reevaluate our assumptions about interstellar objects and their potential significance.
Beyond just the 3I Atlas event, this alignment might also serve as a wake-up call to the scientific community. The possibilities it presents, whether regarding the composition of interstellar dust, the behavior of unusual cosmic objects, or the potential for extraterrestrial life, are vast and far-reaching. After all, what we learn from studying 3I Atlas could extend far beyond this single object. It may open the door to understanding how objects from deep space interact with our solar system, and in turn, how our solar system fits into the grander scheme of the universe. Looking forward, March 16, 2026 will mark another critical point in the journey of 3I Atlas, as it will pass close to Jupiter, within a region where Jupiter's gravity dominates over the Sun's. This encounter could be an even more revealing event, as it will test the object's behavior under the influence of a massive planet's gravitational field. Could this gravitational interaction cause 3I Atlas to shed more particles or alter its trajectory? Could it even deploy satellites, similar to how a spacecraft might use a planet's gravity to assist in its trajectory? These are the sorts of outlandish possibilities that astronomers must prepare for as 3I Atlas continues to defy easy explanations. It's this sense of mystery, this sense of cosmic intrigue that makes 3I Atlas so captivating. As we prepare for the January alignment, we're not just watching another comet pass by. We're looking at an event that could change our understanding of the universe and perhaps even our place within it. Whether it's revealing the true nature of the dust around it or offering new insights into the workings of interstellar objects, 3I Atlas will continue to challenge our perceptions and keep us guessing about what lies beyond the stars. In the end, what's truly remarkable is the way 3I Atlas has captured the collective imagination of the scientific community and the public alike. From the moment it entered our solar system, it has sparked questions about extraterrestrial life, technology, and the future of space exploration. As we look ahead, we can only wonder, will the coming observations unveil answers to these questions, or will they raise even more questions we have yet to imagine?